To test the null hypothesis of mu equals 107 versus the alternative of mu is not equal to 107, a simple random sample of size n equals 35 is obtained. Does the population have to be normally distributed to test the hypothesis? Why or why not? So here, since n is larger than 30, the population does not have to be normally distributed to test the hypothesis. So since n is greater than 30, the population does not have to be normally distributed to test the hypothesis. Oops. So if x is 104 and if x bar is 104 and s is 5.7, approximate the p-value. Now we want to select the range here. So we're going to go to StatCrunch. Close this window down here. So I'm going to go to Stat. Make this a little bit larger here. So Stat and then T-Stats, as we know, our sample standard deviation, but not the population standard deviation. And then one sample with summary. Our sample mean is 104. Our sample standard deviation is 5.7. And our sample size is 35. Our, null hypothesis is that mu is 107. Our alternative is that mu is not equal to 107. We're going to hit compute here, and our p-value is 0.0037. So our p-value is 0.0037. So we want to select the range here. So that's going to be here, right? Now we want to interpret the p-value. So let's round this to 3 decimal places. So this is approximately 0.004. So if we look at this, this is the tenths, hundredths, thousandths. So this is 4 out of 1,000, right? So we're going to interpret the p-value here. That's going to be important. So what we would say here is that if 1,000 random samples of size n equals 35, which is our sample size, are obtained, about 4, so 4 out of 1,000 samples are expected to result in a mean as extreme or more extreme than the one observed if mu equals 107, right? So that's what the p-value interpretation is there.